Welcome to ModPath Chat, the official podcast of modern pathology, featuring interviews with authors and experts on the latest science, technology, and developments in the field of pathology. Your host, Dr. George Netto, is the editor-in-chief of Modern Pathology and the chair of pathology at the University of Alabama at Birmingham. Here's Dr. Netto.
My guest today is Dr. Daniel Hodson, who is a CRUK Senior Cancer Research Fellow at the Wellcome MRC Cambridge Stem Cell Institute. Dr. Hodson is a practicing consultant hematologist at the Cambridge University hospitals. So real-life practicing hematologist. The topic of our discussion today is his recent review in Modern Pathology on genetic profiling in diffuse large B-cell lymphoma. Thank you, Dan, for accepting my invitation.
Thank you, George. And I'm absolutely delighted to be here to talk about one of my favorite topics.
All right. That's used to, believe it or not, a certain time used to be one of my favorite too. I used to love heme path, and then I don't know what happened. Went the wrong way into geopathology, but I still believe it's an amazing subspecialty, and like usual, leading the entire field in terms of molecular and classifications and what have you. And I think that's going to be the topic today. So I tremendously enjoyed reading the review, and we're lucky to have you and your team contribute this to Modern Pathology. But for our audience, why now? Why this is so timely now to write a review?
Sure. Yeah. So, I mean, the review focuses on the molecular profiling in diffuse large B-cell lymphoma. And I think the reason why now is that over the last 4 or 5 years, there's been a flurry of papers that have shown different methods of subtyping diffuse large B-cell lymphoma. So some of these rely on transcriptional methods, and some of these rely on genetic methods, either by whole exome or targeted sequencing. And I think whilst this is tremendously exciting, I think there's also the potential, unless you're immersed in this constantly, to be a bit overwhelmed by papers that whilst in some way they seem to agree, they don't say quite the same thing. And I think perhaps for the practicing histopathologist who's diagnosing diffuse large B-cell lymphoma, I think the question is, what do all these papers mean? What do these new classifications mean to us? Do they agree? Do they say something different? And do I need to worry about them? Is this something that's coming soon to my practice, or is this something that I can perhaps safely ignore? And they're the questions I wanted to address.
That's and we'll try during today's podcast to address as many of these questions as possible. So, can you share with us the salient classifications that you're referring to, or of genetic subtyping? And
So, I mean, I think the first thing that we've recognized for a long time is that diffuse large B-cell lymphoma isn't one disease. And I think at the molecular level, it's multiple different diseases, and possibly it all, we're ultimately going to end up concluding that every case is slightly unique. But I think there are classification systems that can now lump patients together into groups that have similar biology, and that of course then has consequences for prognosis and for different treatment, particularly if we're going to start using molecularly targeted therapies. And broadly, these subtypings can be classified into the ones that use transcriptional profiling, so the sort of what's now relatively old-fashioned, I guess, cell of origin profiling with ABC and GCB. But added to that more recently by the Vancouver group and also by a UK group has been the concept of a double hit signature or dark zone signature or a molecular high grade signature. These all sort of hit on the same thing that we perhaps traditionally call double hit lymphoma. So it's a MYC driven group. But then separate to that, there have been 3 big studies that have looked at genetic subtyping. So they've used a variety of mutational analysis, either whole genome or targeted sequencing. And they've said, when we find a genetic profile for each patient, is it sort of random what mutations a patient has, or does the presence of one mutation make another mutation more likely? And when we look at that, what we find is that there are genetic clusters. So there are clusters where if you have one group of mutations, you're likely to have another group of mutations, and you're much less likely to have mutations in other pathways. And these seem to define a collection of what we call genetic subtypes. And there have been 3 biggish papers over the last 4 or 5 years, and they've independently come to really remarkably similar conclusions. And every time I talk about this, I kind of stress how unusual this is, that 3 completely different groups independently come to really very similar conclusions. So I quote the example of cell of origin, and 20 years ago when that came in, I don't think there was this level of consensus about the transcriptional subtypes, whereas I think now all of the big parties invested in this really agree that there are these sort of 5 to 7 genetic subtypes of diffuse large B-cell lymphoma.
Excellent. So just so we are speaking the same language, the 3 classifications you're referring to, I think you put them in figure 1 in the manuscript: LymphGen, modified HMRN, and the Harvard classification. Are these the 3 you're referring to? Or
yeah, that's exactly it. So the 2018 Margaret Shipp and Bjorn Chapoy from Harvard published their classification in Nature Medicine. Almost exactly the same time, Lou Stout from the NCI published his classification. The NCI then updated theirs, and they published it as a web tool called LymphGen. So you can take a list of mutations, put that into LymphGen, and it gives you a LymphGen classification. So that's a probabilistic classification. It tells you how likely a patient is to belong to any particular subtype. And then around about the same time as that, we in the UK had a study at the Heme Malignancies Research Network, HMRN, in brief, where we sequenced just under 1,000 patients with a targeted panel. And again, came to really very similar conclusions to the Harvard and the NCI studies.
Excellent. And so you touched on that there, like any time classifications come, there may be some differences, but hopefully, for the most part, there's some consensus. Hopefully, better than what we did with bladder cancer when we came with the TCGA, and we keep modifying and finally it took maybe over 6 or 7 years to come up with a good consensus classification. So how is it as far as diffuse large B-cell lymphoma goes?
Yeah, so I mean, as I say, really remarkable levels of agreement on this. So what I think we all agree on are what the big clusters are. So we all agree that there's a sort of, MYD88 CD79B mutant cluster, that there's a sort of follicular lymphoma-like cluster, and that there's sort of 5 to 7 of these clusters. And in fact, each of them, the interesting thing is each looks a bit like an indolent lymphoma or another lymphoma type that we know about. So there's a group that have the same genetics, same biology as what we think of as the extranodal lymphoma, so breast, testis, CNS. There's a group that looks just like a high-grade version of follicular lymphoma. There's a group that looks like a high-grade version of marginal zone lymphoma, a group that looks very like primary mediastinal B-cell lymphoma, and a group that looks a little bit like Richter's transformation. So these clusters, I think we all agree on. Where I think the differences come in between the 3 classifications is how strict you need to be to say a patient's in that group. And that's really reflected on the number of cases that are left unclassified. So the Harvard group classifies almost every patient into one of these groups, and I think has only a 4% or something like that they call unclassified. In the HMRN study, I think we had 27% of patients that we left unclassified, that we couldn't put in one of the groups. And then in the NCI study, I think LymphGen leaves about 40% of patients unclassified. So I don't know. I mean, of course, we don't know what the right answer is, and there probably is no right answer. But I think the main difference between the classifiers at the moment is not what the clusters are, but how strict each classifier is in assigning a patient into it.
And forgive my ignorance, but at this stage, from a practical level, to classify a given tumor in one of these 5 or 7 clusters, do you need to always do whole exome or a large panel, or have you moved to where immunomarkers and maybe FISH can do
Sure.
be surrogates?
So I think we're certainly not there with being able to do this by immunomarkers. I think there's some correlation. So CD10, for instance, which is a very germinal center cell surface marker, that would make a cell much more likely to be in what we call the easy B group, or the one that's more likely to be follicular lymphoma related. But I think using these cell surface markers and immunohistochemistry is simply not granular enough to be able to resolve these genetic subtypes. And then I think the case here is that the more information you have, the better the classification is. And I think the gold standard for this is probably whole exome sequencing. But I think you can go a very long way with 30 or 40, with knowledge of genetic status of 30 or 40 genes. You can probably get most of your classification for that amount of money, but you continue to get more and more improvement the more genetic information you have. And so it becomes a balance really between getting that extra little bit of information, but for what will of course be a lot more sequencing cost.
Correct. And 30 to 40, gene panel, that's now hopefully available in a lot of major centers, and so it's not that bad. The question then becomes, in making that decision, do I want to move to invest more cost? Is if it's going to impact management or not, right? Or it's just an academic exercise. So where do we stand in that regard?
So this is the $1 million question really, which is how useful is this, and does this determine treatment? And I think the answer is, in a prospective way, we've never properly looked, and I almost think we're in a bit of a vicious cycle here with genetics and diffuse large B-cell lymphoma, because it's a big step. It's difficult. It's technically difficult. It requires infrastructure and money. And so, of course, routine diagnostic labs will say, is this going to influence management? And if we say no, then it won't happen. It becomes research. But doing this as a relatively small number of isolated research studies doesn't overcome a lot of the problems that we need to get through in day-to-day practice, and doesn't really tell us what the outcome's going to be in studies. The one thing I can say is, where we start to look in studies, so where we take studies that have potentially been unsuccessful in not meeting their primary endpoint, and we go back and look at the genetics of those studies. And a really good example is the Phoenix study. So it was R-CHOP, which is our standard immunochemotherapy, plus or minus ibrutinib, randomized. That study failed to meet its primary endpoint. So there's no difference overall between the ibrutinib and the placebo-treated patients. But when they went back and started to break up the genetic subtypes, they find that in what turned out to be quite a small number of cases, simply because I think difficulty accessing enough tissue to be able to sequence. So it started from a trial of 800 patients or something, but the actual number of patients that were in the MCD group, for instance, was down to 30 or 40, something like that. But those patients, when they compared the ibrutinib, non-ibrutinib, there were then very large changes in outcome. And what that suggests to me is that, particularly if we take targeted therapies, these really need to be targeted at the biology. And the more we start to look at trials or even patients going through off trial in standard practice, the more we start going to identify which patients respond to which drugs. But at the moment, I have to say, we don't have any prospective trial evidence that a particular patient should receive a particular subtype should receive a particular targeted drug. But I think once we start doing those studies, we will.
So I take it the studies are not ongoing. So is there any prospective study looking at one of these three versus treatment and outcome, better refining the groups that are treated?
Yes, well, there are. Yes, I mean there are. I mean, I think all studies going forward at the moment, all the sort of big phase 3 studies, For instance, we have something called Remodel A in the UK, which randomizes to R-CHOP plus or minus acalabrutinib. All of these studies are now being prospectively sequenced so that we will be able to answer these questions. There was at ASH last year presented at the American Society of Hematology a really interesting study from a Chinese group where they actually upfront just divided patients into molecular subtypes and gave really what I think they thought was their best guess targeted drug for that subtype. And they compared outcomes against historical controls, so it's difficult to really be sure what was going on. But I mean, they appeared to have remarkable outcome responses by giving a sort of R-CHOP backbone plus some kind of targeted drug most suited to the biology of that genetic subtype. But I mean, really, of course, what we need is prospective randomized trials where treatment is stratified by molecular subtype, and that will start to answer these questions.
And hopefully that's on the way. Hopefully.
So these things are coming. Yeah.
Excellent. That's fascinating. And clearly this is not just unique to diffuse large B-cell lymphoma or hematologic neoplasm patients. The same apply to a lot of solid tumor, and hopefully that will be a game changer, because this is the most common type of non-Hodgkin lymphoma. So a lot of patients are impacted by that.
Exactly.
And so let's finish with some take-home message. What are you doing practically now for your patients in your lab, in your hospital in Cambridge, and or at least what would you recommend as the minimum as a practical message to our hematopathologist audience?
Yeah. So I mean, I think the key thing is I'm not saying that treatment should be directed by these mutation subtypes at the moment, but I do think that the more, but I think it will be soon. We have trials coming that will suddenly start to produce a result. And I think what perhaps molecular histopathologists who are working on diffuse large B-cell lymphoma need to be aware is it may be that in 4 or 5 years, all of a sudden, treatment will be directed by the mutation status. And we will at that point be expected in routine practice to be able to deliver an answer on genetic subtypes, or at least a genetic profile. And it's not, there's a lot of logistical hurdles to battle through before we can do that in routine practice. Do we sequence FFPE? One of the problems that we've been having here is tiny little needle biopsies that our interventional radiologists are getting so good at doing that we often have very little DNA left over, or very little material left to make DNA for molecular profiling. And I think that type of logistical problem is something we're only going to iron out if we kind of bite the bullet here and say, well, let's have a go at this and see what the problems that we need to solve. But I think within the next sort of 4 to 5 years, I think it may very well be that routine laboratories will be expected to produce a genetic profile. And so I suppose my take-home message, and the final take-home message from this paper, was now's the time, I think, to get involved and start experimenting with this, because at the moment it's not needed, but I think it's not far off that it really will be needed. And by that stage, we'll have to have ironed out problems with sample management, sample handling, how we make the DNA, whether we use a small panel, a big panel, or an exome, whether we get our DNA from tumor or from circulating plasma DNA, which is something else that I think is a really promising source of DNA, and we're doing a lot of work on that in Cambridge at the moment. But it's coming, and I think we have to start solving some of the technical logistical problems to be able to offer this to our patients.
So liquid biopsies too, here again. Yes.
Yes, I think liquid biopsies have huge promise. I mean, mainly to get around this problem that biopsies are getting smaller and smaller, despite everyone saying we need excision biopsies. We at least in the UK are ending up with a greater and greater proportion coming from tiny needle biopsies, and that there's simply not enough to do everything we want to do on the molecular side. But there's a lot of DNA circulating in the plasma, a lot of tumor DNA circulating in the plasma of patients who present with diffuse large B-cell lymphoma. And we can certainly genotype patients from the tumor DNA circulating in plasma.
So these classifications can be applicable to that on cell-free tumor DNA?
So we're looking at that at the moment, and it very much looks like they are. Yeah.
Excellent. Well, on that positive note, I thank you for coming again, and it was really such a pleasure. So thank you very much.
George, thank you. It's been an absolute pleasure to come and talk to you about it.
Wonderful. And to our listeners, we invite you to also visit our USCAP YouTube channel and follow us on Twitter and spread the word about this wonderful podcast today. Thank you very much.
Any opinions expressed in this podcast are the speaker's own and do not represent the views of Modern Pathology, Springer Nature, UAB, or USCAP. Your ModPath Chat host and scientific director is Dr. George Netto. Producers are Christina Crow, Amber Jackson, Dr. Sarah Jang, and Dr. Catherine Ketchum. Technical direction is provided by Kaminsky Productions, music by Mitch Neubauer. Thanks to the authors, reviewers, and editors of Modern Pathology for making this podcast possible.